To speak here, the Bay Area MicroStrategy user group, Dave Abercrombie, Tapjoy, and I'm going to talk about sort of a general problem in BI. So this is not a MicroStrategy specific issue, but it's kind of a fun issue that's been kind of interested to me, and that is dealing with nulls, unknowns, missing data, this sort of thing. Before we get into that fun little topic, quick review here. Mobile advertising is what we do. We have customers who are app publishers who want to get money, advertisers who want to spend as little money as possible. Of course, we have to keep the users happy, and it's so it's a numbers game. Our data is sort of like your typical web analytics funnel as one goes through interacting with a mobile ad. It's a similar sort of deal. We have big data. We have 500 million global users, a lot of things going on, a huge data stream, and MicroStrategy is only part of our solution. We do an awful lot of predictive analytics and that sort of thing. Our basic architecture is the various mobile devices around the world send a stream of events, or beacons if you will, a click, an open, all these things, a video start. We're getting a constant stream of those that goes into a big data store. And basically, you may have seen this talked about, sort of the Lambda architecture idea, where the current state of the system is determined by basically counting and summing up rows, event-based rows. So that's what we have here. We also have, of course, a operational database that has sort of the various ads, the offers, the apps, and that sort of in it. I'm more of a database person, pretty well steeped in Oracle, made a switch to Vertica Big Data about 6 years ago, and I mostly deal on the data side, the database design, the database architecture, but I also deal a lot with data semantics and metric definitions, which turns out to be very, very important. I occasionally do some MicroStrategy architecture, but Alex does most of that. So here's what I'm going to talk about. Basically, missing data is hard to deal with, and you have to deal with it properly to get your BI system, your MicroStrategy, to come up with the right numbers and gain user confidence. So I've got a very simple approach for organizing or defining the different types of missing data. You'll see that. And I want to talk a little bit about how we structure our ETL process to gracefully deal with unknowns. So with all the tools we have nowadays, and around the room we talked about a lot of different tools, it's actually getting pretty easy to move large amounts of data around and sum them up. You know, the data management problems have basically been solved, and there's a lot of tools out there to move and store your data. But the hard part, I think, an interesting hard part, is dealing with unknowns. And missing data, glitches upstream, nulls in your data set, codes that don't match up. If you don't deal with the little glitchy edges of missing data, then your numbers aren't going to really add up right. But if you deal with that gracefully, it works out very well. And that's actually very hard. People don't want to think about missing data. It's much easier to think about summing up things that exist than how you deal with things that don't exist. But I really want to stress that to deal with those unknowns is really the key to getting good accuracy in the reporting system, and user confidence depends upon getting those details right, that the numbers add up right, that the daily revenue is correct, even in spite of missing and unknown data. And it's only through that careful attention to these issues and getting the accuracy right that you're going to have your users will have confidence in the system, and the system will be a success. So what I think that this is really It's just glitchy little edges around the data, but I think it's really key to success of a project. So who cares about missing data and little glitches? Well, for one thing, data science people typically don't care about the occasional null or a little bit of data. You know, if 1% or 2% of the data is missing, it's not going to change their algorithms. It's not going to change the predictive algorithm. So with a kind of data stream, with these large event-based data streams, there's always going to be glitches, and the data science people really don't care. Another group of people you might work with who don't really care so much are the data pipeline engineers, the folks who keep the data flowing from one system to another. You know, their job is to keep the data flowing, keep those queues from getting built up. They're not as concerned with the semantics and nuances of missing data and things that don't line up right. Do the users care? Well, they don't really want to think about missing data. They don't, you know, it's hard to think about, it's hard to discuss, but they want their numbers to come out right. So that basically falls to the BI data warehousing people that deal with this stuff gracefully and accurately. And it's hard work. I mean, really, the semantics of BI and semantics of your data, I think, is much harder than a lot of the engineering. You know, what does this event mean? It's what kind of metrics do we have, and what sort of products deliver what kind of metrics? Those issues are very complicated, a lot of subtleties, and typically it kind of can fall between the cracks in many organizations. So that's why I'm here to talk about this very briefly. So where does this missing data come from? I think there's basically two places where missing data comes from. If you can even say that, I mean, if the data's not there, how could it, where would it have come from? Anyway, there could be, you know, we have this event stream coming in, and occasionally we get a certain column or field that we expect to have data, but it can be null. And the null data, sometimes it's quite legitimate. You know, maybe that particular column is not relevant for the context of that event. Sometimes it's due to a bug in the application code. The engineers forgot to instrument that detail in the event stream. Sometimes it's due to glitches upstream. You know, there's a lot of things that could go wrong, and sometimes the data gets a little fouled up. I put on the list here the empty strings, which annoy the heck out of me. I don't know if you guys have to deal with empty strings. They're sort of like nulls, but they're not really. So those are all kind of nulls in the upstream data. There's another type of null that can come about while you're processing the data. That's when you're typically in an ETL process, you may need to do some lookups to some of your dimension tables. Typically, you're going to want to do a left join between your event data and the dimension data. And it could be that things don't match up right. You could have like an app ID in your event data that you can't find in your operational database. And you don't want to just throw that into your system. You need to deal with it gracefully. So, and I don't know, do many of you use surrogate keys in your data warehouse? Show of hands who has a surrogate key basis. So they're good, okay, they're pretty common. They're, when I talk to my data science people or my data pipeline engineers, they say, what the hell is a surrogate key? No, that's just a hassle. But good, I'm speaking to people who know and appreciate them. One specific kind of use case or case study where nulls can come about that I want to talk about is what I'm calling out-of-sequence facts. In our system, we have the fact data is an event stream that comes through one pipeline, and then we have the dimensional data that we extract out of our operational databases. And it could be that when we're processing some of the fact data and we look it up in our dimensions, for instance, to assign a surrogate key, it may not be there. And sometimes, you know, for instance, we have very loose dependencies between our different ETLs. So it's not necessarily a bug. We allow it to happen that facts that contain certain ideas arrive at the ETL system before the data that defines those ideas is present. That's what I mean by out of sequence. The fact comes before you understand what those ideas are. Of course, one way you can deal with that is by having a lot of dependencies in your ETL system. You could say, well, I can only process these event-based facts if I've already processed the hourly dimension data for that. But if you have a lot of dependencies in your ETL system, it could be subject to getting gummed up and stopped. If a little minor dimension ETL fails or delayed, it could delay your whole fact processing. So we wanted to minimize that sort of dependency so that we could process the facts gracefully, even if the dimension ETLs were behind schedule. And of course, you could also sometimes have bugs in the data. You could get an ID, let's say for an app, that doesn't really exist. It's a bad ID, and you can't really tell the difference. So that's one example. So basically, the way Tapjoy deals with it, we have kind of three categories of unknowns. There's nulls in the upstream data that are completely valid. For instance, in our system, an app could request an ad from the service, from the servers. Here, we're going to call it an offer. So the app requests an offer, but it's requesting any offer. It doesn't have a particular offer, so that request does not have an offer ID with it. So the event, in this case, it would be valid to have a null offer ID. That's natural and only reasonable for the semantics of that sort of an event. So that's an example of a null that's perfectly acceptable. You might find in your event data nulls that are unacceptable. So for instance, since everything we do is in an app, we expect every event to be tagged with an app ID. And if it's not there, that's a problem. The instrumentation is screwed up. You know, we expect it. So that's an invalid buggy null in the upstream data. So a null upstream can either be valid or invalid. And then you get your nulls from doing your left join lookup into your dimensional data, your definitional lookup tables. It could be that it's an out of sequence issue, like I just talked about, the previous example, or it could be a buggy ID that somehow the instrumentation was screwed up. At this point, we can't tell. It didn't match, that's all we know. What we have done is we've assigned kind of magic code values for each one of these nulls. They're out of order here, 0, -2, and -1. So we have three different kinds of nulls. Now, just as an aside, there are some databases, like for instance, there's a scientific database called SciDB that allows you to define several hundred different flavors of nulls. You know, we're sort of used to most databases just have null. Is it null or not? But in some cases, you have to have different flavors of nulls. So here we've basically got 3 flavors of null, but some systems have many more than 3. So talking about nulls in the upstream data, is it a valid or an invalid null? Well, sitting at the tail end of the data pipeline in BI and MicroStrategy, it's not obvious looking at it. It really requires speaking to the engineers, talking to the product people. Do we expect a null here or not? It's actually hard work, because a lot of times, again, these engineers don't really think about nulls or missing data. In some cases, there may be a bug in the application logic, and you may need to consider that an invalid null is okay, and just process the data as if everything was fine and dandy. That way you get the data into the system, and eventually, when they fix the code, you'll start to get non-null values there. So even this notion of, is an upstream null, is it valid or not, can be non-trivial to solve. And what we've found at Tapjoy is you really need to be able to make this decision and this assignment at a very granular level. It may depend upon the metric. It may depend upon the product that's generating this. It varies at a very granular level. So you can't just make a blanket assignment of all nulls are invalid or all nulls are valid. It requires a way to manage it at a very granular level. So here's the basic approach that Tapjoy has settled upon for a flow. Basically, this is kind of the key slide of what I want to talk about here, and the system we use in our ETL to solve all of these problems. So basically, when we process the data, we make a determination which nulls are valid, and we give them the code of 0. That's like the valid null code. And those kind of rows are okay to take from your ETL process and append to your fact data right away. You've said that null's okay, you've got a code for it, you put that data into your facts. Now you're left with rows with the other types of nulls, the -1 or the -2 type errors. We run our ETLs hourly, and what we do is we take the -1 errors, the nulls that come from left join, where the right side was null, and we put those away in a little error table. We don't add them to the facts, but we store them. And then the next hour, when we bring that data back in, or when we process the next batch of raw data, we bring in these errors that previously didn't match up. Maybe by now, the dimension ETLs have caught up, and so this time they will match, in which case they'll no longer be a null, will no longer be a -1 error, and they'll go straight into the system. If they still don't match, we put them back into the error table. And we just keep trying again. Now, if you do something like this, you want to avoid an endless loop of buggy data filling up your error tables. Of course, you need to put a time limit on there. We have like a 2-day time limit on that. But having these error tables allows you to assess and diagnose what's going on with your nulls. The data is tucked away. You can see what columns are getting nulls. We also put the -2 type errors in there. That would be the nulls that are unacceptable to us and will never make it into the data warehouse, an unrecoverable sort of null. We put those in the error tables too, just so we can look at them and find out what's going on in the system. One thing we've learned when doing this, of course, you may have a dimension hierarchy. So with a dimension hierarchy, if you need to make sure that you deal with your unknowns at all levels in the hierarchy. For instance, if we have a row in our app dimension for the missing app, and that's in a hierarchy, and above that is the publishing partner. So that missing app belongs to the missing partner. So you want to make sure that you've got a clean hierarchy that deals completely with these error codes. We put all these error codes in the dimension tables themselves and expose them to MicroStrategy. That way we can look. We don't get any foreign key violations when we are doing our reports. We can use MicroStrategy to look to see, are we getting some of these errors into the system by mistake, and this sort of thing. And when it comes to dimension hierarchies, you may have a little bit more complications to deal with things a little bit gracefully. So for instance, we have a slightly different, we have like when an event comes in, it has the device name associated with it. We look up the name in a lookup table to see, is this a phone or a tablet based on its name. And we may have rows that don't match up. And so that's, again, sort of an unknown. You need to think a little bit more about this when it comes to the dimensional stuff. And since you're exposing this stuff to the users the unknown app, the missing app. They require a little bit of education, and when they start seeing these unknowns, they can often be confused. You know, what's the difference between an unknown and an unmapped? It's subtle. They need some education. So that's about all I've got here. What I talked about is how missing data is hard to deal with, that semantics is hard, not only for nulls, but just in general. The semantics of your data, the meaning of your data, it often gets not the attention it deserves. It's helpful to work out a taxonomy of missing data. We're able to do it with 3 different flavors of nulls that have a consistent sort of magic value coding scheme throughout our systems. And it's real important that as you're dealing with this stuff that you do it at a very granular level, so you can treat one metric or one fact appropriate to it, and treat another fact a different way, and even divide it up within parts of your company like product groups. And I've given you a simple little ETL data flow, how to handle this, that notion of putting these missing data in an error table, bringing that back in, trying again each hour is really very helpful. And definitely you need to talk to users about this. So that's the end of my little presentation on missing data.